If you think you have the right answer to this limit problem, you're about to learn in just a few minutes how to prove if you're correct or not. And the answer is surprising, believe it or not. For sticking around, I'm also going to give you a bonus tip as well. When you look at this problem here, it's not enough to just say that because x is multiplied by a trig function that oscillates up and down, that we know what the answer is. We have to show more work on our exams, right? So I'm going to go ahead and use a really cool substitution trick. I'm going to let u equal 1 over square root of x. And also I have to solve that for x because we need to be able to substitute something in terms of u for this x term that's in the original expression. So by taking the reciprocal of both sides for this substitution, we'll find that 1 over u equals the square root of x. And then by squaring both sides, we find that x equals 1 over u squared. But wait, hold on, there's something else we have to do here. Remember that x was approaching infinity, but because we have this substitution here for u, we have to rewrite what we are approaching in terms of u. Because this denominator is growing arbitrarily large, we know then that u is approaching 0. So now we have all the info we need to rewrite this problem in terms of a limit that's expressed for the variable u. So now it's going to approach 0 this time, and we are now having a product inside the limit of 1 over u squared, aka this was your old x, times the sine of u. And what I'm going to do as my next step here is I'm going to rewrite this multiplication of these two terms as a product of two fractions, 1 over u and sine of u over u. And the reason why I'm doing this is because I did promise you a bonus tip that's really important to call out here. Before I mention it, I absolutely love making videos for you guys. And if you want to support the growth of my channel and watching more content, you can become a member in the description below where I'm going to give you bonus videos and you're going to be able to watch my videos early as well. In addition to that, you're going to be able to get priority replies from me in the chat and more. So looking at this problem here, here's your bonus tip. Can you break this limit up into a product of two separate limits? Let me know below and think about it for a second. Okay, so if you think you can actually split this up, the answer is you cannot. Normally with the limit product rule, yes, you generally can split up a limit of two things that are multiplied together to then have a product of two separate limits, but that requires that those two things are convergent. So let's look at each one by one. The limit as u approaches 0 of sine of u over u here is known as that famous squeeze limit theorem. We know that that converges to 1, and that's an example limit I cover in a video like you see above. But what about this 1 over u part, right? It's not really clear. I mean, you might see the answer already, but let's go ahead and do something else. Instead of blindly assuming, we can split this up. I have another video you can check out above, and it comes from the Taylor series, and also squeeze limit theorem shows this as well. But for this sine of u term here, because u is approaching 0, think about when u is a very, very, very small value that's a neighbor of 0. That tells us that sine of u approximately equals u. So what this means then is if we were to go ahead and plug this in, since the limit already is talking about getting really, really close to the value of 0, this term on the right now becomes u over u. And this all simplifies to simply finding the limit as u approaches 0 of 1 over u. But we have to be careful here. I'm noting with this plus sign that we already know that this is a right-hand limit and a right-hand limit only, because in the original problem when x was approaching infinity, when we did our substitution for u, we already know that we are only dealing with non-negative values and we're going to be approaching 0 from the right. So by inspection, this is a pretty straightforward limit, right? This denominator is getting arbitrarily large. And because we're only approaching from the right direction towards the left, we know that this limit is going to rapidly approach positive infinity, telling us that for the original problem, the limit does not exist.